Hello everyone, my name is Franco Pucci and I am the technical consultant for the STS Association. I've been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of STS and the STS standard. I hope you find these videos helpful. In this video we will continue with the various clauses of the specifications. We'll deal with mainly clauses in the IEC 62055-41. The -51 and 52 we will periodically talk about, but not in any great depth. So this video will be section 6 of the 41 spec, and that is still under data elements of the ADPU and definitions. And the reference source obviously is the document itself. So let's start with key type, which is in clause 6.1.9 and clause 65231 of the document. The key type is a one-digit number in the range 0 to 3, associated with a type of key used to encrypt or decrypt tokens. The meter itself must be able to store at least one key. It could store two. It must never be able to read the decoder key from, you must never be able to read the decoder key from the meter's memory at any time. Once the meter has been coded with a key, it becomes completely opaque to reading from the outside. The following key types are specified in the document. Key type 0 is there is no SGC associated with it. It's an initialization key, and its use is for meter initialization when it's first produced or repaired in the factory. This is the only key that is available to be actually read in plain text by selected people within a company. None of the other keys are ever seen. Key type 1 is a default key, or DDTK. This key is used typically to ship the meters, for example, to a large warehouse where the destination supply group code is not known. They get stored in the warehouse, and then once the utility or the customer wants to ship them out to various areas, he will then code them to a particular supply group code. In a default state, you cannot vend credit to a meter. So in other words, you can't get them stolen out of a warehouse and installed in a home and vend credit to it. Key type 2 is a unique key, or DUTK, and that typically can be used in a keypad or a mag card. And that is what 99% of the meters installed in the field are key type 2. Key type 3 is a common key, or DCTK, and that can only be used in mag cards. Remember that for a supply group code that's sitting, a DCTK supply group code, it means that any meter in that supply group has exactly the same key. Typically this would be used for small little areas where somebody just wants to keep a stack of 10 kilowatt hour tokens, say, and issue these tokens periodically to the tenants. He doesn't have to know which meter it is, he just issues a token. That token, however, can be played to any one of those meters within the supply group. Key expiry number, that's in clause 6.1.10. And if we look at the structure of a token, a typical class 0 token, which is a credit token, in this case it's subclass 0 as well, which is electricity. The random number can be anything from 0 to 15. In this case it's 0101, which is 5 decimal. The token identifier is the next 24 bits, then you have an amount and you have a CRC. The top 8 bits, the ones shown in red, okay, correspond to a number of minutes. The 8 Ken bits in red correspond to, essentially, if you work it out, 45.51 days multiplied by the value of the Ken. So with a Ken of 01, for example, tokens will be valid for 45.51 days since the start of the base date. With a Ken value of 8, it will be 45.51 times 8. In other words, the tokens will be valid or the meter will accept tokens for 364 days since the start of the base date, and so on. For a Ken value of FF, the tokens will be valid for 45.51 times 255, which is 11613 days, or 31.8 years. This means that the Ken, the TID rather, has a maximum value of 31.8 years. The resolution of the Ken is therefore 45.51 days, and this is how the key expiry number is used. Let's have a look at some key expiry number examples. If you have a key expiry number stored in the payment meter of FF, which is 255 decimal, it means that any token with a Ken value of 0 to FF, which is the 1st of the 1st 1993, the start of the base date, up to the 24th of the 11th 2024 at 20:15 in the evening, that's the end of the base date for a 1993 base date, then the tokens will be accepted, since the Ken is always less than or equal to that value. So in other words, all tokens are accepted. For a 2014 base date, it'll be from the 1st of the 1st 2014 to the 24th of the 11th 2045. Okay, effectively all tokens accepted during that base date, which means that effectively if you set 255 for the key expiry number, this is disabled because it'll accept tokens for the entire duration of the base date. However, for a value of AA, say, which is 170 decimal, then any token between 0 and AA will be accepted, since the TID is less than or equal to the Ken value. But if your Ken comes in with a value of AB up to FF, the token will be rejected, since the TID is now greater than the key expiry number. And that's essentially how the key expiry number works. Date of expiry, which is clause 6.1.11. This is the validity period for identity related data in a meter card, for example. This is optional, it doesn't have to be used. It can be encoded into a meter card, say for a concessionary tariff for a period of time. And it's encoded as year, month, where year of 00 means it's disabled, or this is the year 2000. That's past, which means from now on 00 will mean it's disabled. And 01 to 78 means 2001 to 2078. The month, again, if it's 00, it means the date is not used. Or 1 to 12 is January to December, and 13 to 99 is invalid. The base date, or BD as it's abbreviated to, clause 6.1.12 and 6.3.5, is a 2-digit number representing a date marker from which the time the TID value is calculated. Okay. So, a base date of 1993, its use is from the 1st of January 1993 at 12 midnight. For a 2014 base date, it starts at the 1st of January 2014 with at midnight, and a 2035 base date, 1st of January 2035 from midnight. The TID value of the token will start incrementing from the base date of the meter. So if you're building a 2014 base date, 1st of January 2014 at midnight, it'll have a TID value of 0. 1 minute past midnight, it'll have a TID value of 1. But we'll look at this a little more when we look at the TID rollover. And that brings us to the end of this short video. I hope you found the video helpful, and hope you will join us for the rest of the series. Goodbye, and see you again soon.